Okay, so previously in chapters 13 and 14, we talked about switching and switching concepts. This actually is just kind of a continuation of that in a way as we go on to chapter 15, virtual LANs. VLANs are actually a pretty integral part of switching, so let's begin. In general, switches break up collision domains and routers break up broadcast domains. So to reiterate what we've covered in the past, a collision domain is basically like a shared medium where packets. It's a layer one issue where packets and electrical signals could potentially actually collide with each other. Hubs and repeaters, they don't break up collision domains. It's all going to be on the same. But a switch actually breaks up each port into a separate collision domain so that you're not on a shared medium for all the devices on there. And then in general, routers break up broadcast domains, and by that we're talking about layer 2 broadcasts of traffic where they're trying to figure out where frames need to go. With the use of VLANs, switches can also break up broadcast domains where you have one broadcast domain per VLAN created. So you can actually break up broadcast domains with switches. On the exam, though, if you have a question that asks, what breaks up collision domains and what breaks up broadcast domains, and it's very possible you will get a question almost exactly like that. Unless VLANs are specifically mentioned in that question, just remember that switches break up collision domains and routers break up broadcast domains, even though what we're about to talk about, VLANs, do serve that function. By segmenting different groups of users into VLANs, broadcast and multicast traffic is significantly limited. So rather than having every single router or every single device connected to that switch sharing a broadcast domain for multicast and broadcast traffic, each of those is broken up for per VLAN. So users on one VLAN cannot communicate with users on another VLAN without the use of a router, even if they are connected to the same switch. Unless also they have potentially a layer 3 switch. We'll talk about that in a little bit. But basically, since you're only at layer 2, each VLAN is a different routing domain. You have to have a router so that they can interconnect with each other. A separate instance of STP also runs for each VLAN. This is known as per VLAN spanning tree, PVST. Requiring a root bridge election and calculations for each of those instances. So, whenever we talked about STP and RSTP in the previous chapters, whenever you have multiple VLANs, you're going to have different calculations running for each of those because, one switch might not have any users for that particular VLAN on it, so it's going to have a different set of calculations for the root bridge election. So, VLAN membership methods. VLANs are generally statically assigned on a per port basis configured as an access port, but a VLAN membership policy server, a VMPS, can also be used, which basically maps configured MAC addresses to a particular VLAN regardless of the port the device connects to. That's a less used type. Usually the top one here where it's statically assigned per port is going to be more common, but you can set up one of these servers where you basically have a list of all of the various MAC addresses for your equipment that could potentially connect to a switch. As soon as the device connects and it builds a CAM entry into that switch, switch is going to consult the policy server and realize, well, hey, this is this MAC address, and I can see based on the server that it's assigned to this VLAN. I'm going to dynamically assign this port to that VLAN because I know that's where that equipment belongs.
The VLAN membership policy server, could that also be sort of implemented as some sort of security feature because it's based on the MAC address?
Yeah, and we actually, when you get later into the chapter, it actually talks about statically, you can do that on a per port basis too, because you can statically map one particular MAC address to a port in addition to setting a policy. This isn't necessarily going to be a straight up, well, unless it's done exclusively through the VMPS, it's not going to be really a security feature. Because you can still have extraneous devices connect, but in most cases, whenever they do that, they're going to have devices that are not statically mapped to a particular MAC address, allocated to a VLAN that probably does not have routing set up to it. So you can set up like a dummy VLAN where any devices that aren't specifically set to map to one place or another, they're going to go to this VLAN, and that VLAN, it won't actually route anywhere because it's not set up to route outside of that particular VLAN. So in talking about like you know, the things we've just discussed, this map right here is kind of a small version of kind of what's going on. So you know, you got your switch here, you've got various ports with various devices connected to it. Over here, ports, you know, assuming these are statically set, ports fast Ethernet 0/5 and 0/4 have been set to switch port for VLAN 3, and likewise port number 2 over here as well. And then 3 and 1 are each set for VLAN 1. So since we've just got a switch here, these guys are, you know, sharing a broadcast domain. These guys over here are also sharing a separate broadcast domain. Since we don't have a router here, and presumably this isn't a layer 3 switch, we don't have routing between them, but we do at least have the broadcast and multicast traffic segmented. So something else to discuss on VLANs is the management VLAN. Every port on the switch is automatically assigned to the default VLAN, which happens to be VLAN 1, unless you configure it otherwise. VLAN 1 is commonly known as the management VLAN. It's if the management IP of the switch is assigned to VLAN 1, you must have access to VLAN 1 from your particular workstation, or you'll lose the capability to reach that IP for remote management using Telnet SSH, HTTP, or SNMP. And basically what that means is if you're trying to, you know, from a LAN side device, access the switch to do any kind of management, you know, any kind of configurations or that kind of thing. If you're trying to access it via Telnet or SSH, basically anything but a console cable, you've got to make sure the device that you're actually trying to access that from is in VLAN 1. If you're in any other VLAN, you're not going to be able to access that, since that's you know, you're not going to have any routing there. Okay, so for configuring VLANs, all interfaces are already assigned to VLAN 1, as we said before. You must create additional VLANs and assign ports to them in order to segment segment groups of users into broadcast domains. First step you're going to want to do is create the VLAN. It can be anywhere from 2 to 1001. Whenever we talk about transparent mode, you can actually go beyond this, but if you use a VLAN outside of this range, like, you know, 1002 and beyond, it's only going to apply on that particular switch. You're not going to be able to apply those changes to other switches in the network. That's kind of a bit of a tangent I probably shouldn't really touch on right now, but in general, the VLANs you create need to be between 2 and 1001. VLAN 1, of course, already exists. Once you create it, it's always a good idea to go ahead and just name the VLAN. If you don't name it, it'll just take the name of VLAN and then 4 digits, whatever the VLAN number happens to be. So if you created VLAN number 2, you didn't go through the trouble of naming it, the name would be VLAN 0002, you know, etc., so on and so forth. So once you've created the VLAN and named the VLAN, you assign it to a switch port. And so continuing with that, here's basically the configuration. So from global configuration mode on the switch, VLAN space 3 creates VLAN 3. You notice it jumps you into VLAN configuration mode on the switch. Went ahead and named it HR Dept for HR department. That's something else I guess I may have not touched on enough, is one of the main reasons you're going to want to segment groups of users is, one, you want to make sure that your broadcast and multicast traffic isn't taking up too much of your available bandwidth, but you're also likely to break up groups of users that are more likely to access the same types of resources. So, like, for instance, if you've got you know, an engineering department, an HR department, and a sales department, it would make sense to logically break up each of those individual departments into their separate VLANs, because presumably, if they're going to have to you know, send any broadcast or multicast traffic, it's probably going to apply to either you know, other users on that same VLAN, or at least other servers and equipment on that same VLAN if you're not going to have to route out of it. That being said, back to the actual configuration, named it as HR department, exited out, and you can see that once we exit, we're back to global configuration mode. We'll go ahead and create another one, VLAN 4. In this case, we did not name it, so the name is going to be VLAN 0004. And then, so we've got them named, created and named where applicable, and then we assign them to our individual ports.